All right, so now we're going to talk about section 5.4 curve sketching. Basically, don't get caught up on the word curve sketching in this sense right here because it's not really what you think. We're really going to take everything we've been learning about first derivatives, second derivatives, concavity, increasing, decreasing, relative min, relative max, point of inflections. We're going to put it all together in one problem so that way we can actually figure out lots of information about what's going on. So that's where we're going to start here. No new definitions, nothing. This is just straight. We're just putting the last couple sections together to be able to create this one. Excuse me. So we're told find out the interval where the function is increasing and concave down. So increasing means we're talking about first derivative stuff. Concavity means second derivative. So it means we got to have both of these in order to do anything here. So f prime of x is 4x cubed minus 24x squared plus 36x. Our second derivative is 12x squared minus 48x plus 36. So let's go ahead and factor each one of these. So out of the first one, we can factor out a 4x, and this is going to be x squared minus 6x plus 9, which would then easily factor to 4x times x minus 3, x minus 3. If we repeat the same thing for the second one, the second derivative, we can factor a 12 out. So we're left with x squared minus 4x plus 3, which would nicely factor to 12 times x minus 3, x minus 1. So for both of these, we want to set them equal to 0 and solve. So my first derivative, it gives me x equals 0 from this term, and x equals 3 from both of these terms by setting them equal to 0. So let's go ahead and work with those. We know for increasing, decreasing, we need to plot both of these on our number line. We need to pick a value to the left and right of each one of these, excuse me, that we're going to plug into our derivative. So if we use a shortened form of our derivative of 4x times x minus 3 all squared, we're going to plug these values into there. So when we plug in -1, 4 times -1 times -1 minus 3 squared, we get -4 times -4 squared. So -4 times 16 is -64. We get a negative. We plug in 1, 4 times 1 minus 3 squared. We get 4 times -2 squared. So 4 times 4 gives us 16. It's positive. Plugging in 4, so 4 times 4 times 4 minus 3 squared gives us 16 times 1 squared, which is 16. It's positive. Because we had that 3 was a double root there, it may or may not change on top of it. So that's for our first derivative. For our second derivative, we get x equals 3 and x equals 1. So we put 1, we put 3, we plug in a value to the left, in between, and to the right. So 12 times 0 minus 3 times 0 minus 1 gives us 12 times -3 times -1, which is 12 times 3, which is 36, which is positive. Plugging in 2, 12 times 2 minus 3 times 2 minus 1 gives me 12 times -1 times 1, which is -12, so it's negative. 12 times 4 minus 3 times 4 minus 1 gives me 12 times 1 times 3, which is 36, which is positive. So what we really need to do here now is we need to put this graph and this graph on the same exact axis, or the same graph. So to do that, I'm going to draw it out here. So for our first derivative, so we're going to have first derivative and we're going to have second derivative. So for my first derivative, I have the points 0 and 3. And what I'm going to do is I'm just going to kind of go ahead and create this. So for my first derivative, I go negative, positive, positive. For my second derivative, I have 1 and 3. So for the second row, to the left of 1, everywhere is a positive. So that means I have positive, positive. To the right of 1, between 1 and 3, I have the negative. To the right of 3, I have positive. So I'm going to change up this one. So for my top piece here, just to make it a little bit, between 0 and 3, it's positive. So positive, positive. So now let's come back and see what this question asked us. We're looking for increasing and concave down. So what we're looking for increasing, I'm looking for the pluses up top. So increasing is up top, concavity or concave down is what we're looking for. So we're looking for a plus up here. We're looking for a minus over here. So we're looking for the plus over the minus, which happens right here. So this graph is increasing and concave down in the interval 1 to 3. It's a lot of work, but it's stuff we already know how to do. So let's do the same thing for this one. F prime of x is minus 6x e to the minus 3x squared. F double prime of x is minus 6e to the minus 3x squared plus negative 6x times minus 6x e to the minus 3x squared. So minus 6e to the minus 3x squared plus 12x squared e to the minus 3x squared. If we wanted to simplify this a little bit, we could pull a minus 6e to the minus 3x squared out to make this 1 minus 2x squared. It'll make it easier whenever we go to factor this. So if we set the first derivative equal to 0, e to the minus 3x squared is never 0. So the only case we have is minus 6x. So we get x equals 0. Same thing with our second derivative, minus 6e to the minus 3x squared is never 0. So 1 minus 2x squared equals 0. So 1 equals 2x squared. So 1/2 equals x squared. Tells us x equals plus or minus the square root of 2 over 2. Another ugly one just like we had in the last section. So for our first derivative here, we use 0, so we got negative 1 and 1. Since e is never 0, it's always a value. So we have minus 6 times minus 1 e to the minus 3 times 1 negative 1 squared. That gives us 6e to the minus third. We pull up our calculator. This value is approximately 0.29, so therefore it's positive. Plugging in 1, we get minus 6 times 1e to the minus 3 times 1 squared, so minus 6e to the minus third. So we would get approximately negative 0.29, so it's negative there. So now we can come down here to our second derivative, negative square root of 2 over 2, square root of 2 over 2. We could pick 0, we could pick negative 2, and we could pick positive 2. So when we plug in to our derivative here, our second derivative, we're plugging in right here. We're going to plug in these values to see what we get. So minus 6e to the minus 3 times minus 2 squared times 1 minus 2 times negative 2 squared. So this gives us minus 6e to the minus 12th times 1 minus 8. So 1 minus 8 is negative 7. Negative 7 times negative 6 is 42e to the negative 12th, which should just give us a really small positive decimal. Yeah, this is approximately 2.6 times 10 to the negative fourth, or 0.000258. So it's a positive value. So it's a positive value. When we plug in 0, minus 6e to the 0, 1 minus 0. So we get minus 6, so it's negative. Doesn't matter if we plug in 2 or negative 2, we still get to the same answer, minus 6e to the minus 12th times 1 minus 8. We still get 42e to the minus 12th. So therefore, this one's going to be positive as well. Didn't matter whether we plugged in positive or negative because of the fact that it was squared everywhere for x. So since it's squared, plus or minus doesn't matter. So now we need to put these two together. So we've got negative root 2 over 2, we've got 0, and we've got square root of 2 over 2. So for our first derivative, everything to the left of 0 is positive. Everything to the right of 0 is negative. For our second derivative, everything to the left of negative root 2 over 2 is positive. Between negative root 2 over 2 and positive root 2, we're negative. And to the right, we are positive. So again, we're looking for increasing and concave down. So therefore, our only case is right here. So increasing and concave down occurs for this one, negative root 2 over 2, comma 0. So we can get into some ugly numbers, but it's still the same exact process. So on this one, we're looking for concave down and decreasing. So we're looking for negative over negative in this case. So f prime of x, so low d high minus high d low over the bottom squared. Make sure that you simplify this. So when we simplify here, we're going to get x squared plus 1 minus 2x squared. So minus x squared plus 1 over x squared plus 1 squared. So now we need to take its derivative. So low d high minus high d low over the bottom squared. Now keep in mind in this case, we have an x squared plus 1 in common everywhere. So I can cancel here. I can cancel one of them here. I can cancel one of them here. So I'm going to be left with minus 2x to the third minus 2x plus 4x cubed minus 4x all over x squared plus 1 to the third. And if we simplify that, we get 2x to the third minus 6x over x squared plus 1 to the third. Now, the good thing between our first derivative and second derivative is we don't have to worry about the denominators. We only have to worry about the numerators. So that tells us minus x squared plus 1 equals 0. 1 equals x squared. X equals plus or minus 1. For our second derivative, we did the same thing. 2x cubed minus 6x equals 0. Take out a 2x. So we have x squared minus 3 equals 0. Means x equals 0. X equals plus or minus the square root of 3. So for our first derivative, negative 1 and 1, we could use 0, negative 2, and positive 2. Our denominator is always positive. So really what we're looking for is the numerator, which really just means negative x squared plus 1. So when you plug in negative 2, you get negative of negative 2 squared plus 1, which is negative 4 plus 1, which is negative 3. So it's negative. 2 is going to give us the same exact thing because of the squared. When you plug in 0 minus 0 squared plus 1 gives us 1, which is positive. Same thing for our second derivative. We only have to focus in on the numerator. So we're going to get negative root 3, 0, and square root of 3. Hopefully by now we are able to plug in and everything. So I'm going to skip that step here. So when we plug in, we plugged in 1. So when we plug in 1, we get 2 minus 6, which is negative. Positive, negative, positive. So then putting both of these together, we've got to put in negative root 3, negative 1, 0, 1, square root of 3. So to the left of negative 1, we're negative. Between negative 1 and 1, we are positive. To the right of 1, we are negative. To the left of negative root 3, we're negative. Between negative root 3 and 0, we are positive. between 0 and negative root 3, we're negative. And then to the right, we are positive. This problem asked us for concave down and decreasing, so we need negative over negative, which is here and here. So our solution here for decreasing and concave down is negative infinity to negative root 3, and then from 1 to square root of 3. So that would be our two intervals in this case. So it's a little bit long, but it's the same process every single time that we're doing here. So looking where the function is concave up and increasing, so we need positive over positive. F prime of x is minus 6x squared minus 18x plus 108. F double prime of x is minus 12x minus 18 equals 0. So minus 12x equals 18. X equals negative 18. I'm sorry, positive 18. Over negative 12, which is negative 3 over 2. For the top one, let's pull out a minus 6. So that's x squared plus 3x minus 108 divided by 6 gives us 18. So then we could factor this to x plus 6, x minus 3. So x equals negative 6, x equals 3. So working with our first derivative here. So we use negative 6 and positive 3. We could pick 0, pick negative 7, you could pick 4. So when we plug 0 into our first derivative here, we're going to get a positive, which means we get negatives on the other two. Doing the same thing for our second derivative, we're going to use it around negative 3 over 2. So if you plugged in 0, you got negative. Plugged in negative 2, you get positive. So we're looking for positive over positive when we combine these two. So for our first derivative, we're going to have negative to the left of negative 6. We're going to have positive everywhere in between that and 3, negative to the right. To the left of negative 3 over 2 for the second derivative, we're going to have plus, plus, minus, minus. So we're looking for, what did I just say? Up and increasing only happens in one spot. So increasing and up means negative 6 to negative 3 over 2. So like I said, nothing new in this section, just putting everything together. So for this problem, find the extrema and the points of inflection. So what that means, points of inflection means f double prime. So f prime of x is low d high minus high d low over the bottom squared. That gives us 1 minus ln x over x squared. Now our second derivative is low d high minus high d low over the bottom squared. So you get minus x minus 2x plus 2x ln x over x to the fourth. Everything is divisible by x. So you get minus 3 plus 2 ln x over x cubed. Now, since we started with a natural log of x, x had to be greater than 0, so x is not in our, x equals 0 is not in our domain. So we do not have to worry about that in either case. So when we set this one equal to 0, 1 minus ln x equals 0. 1 minus ln x equals 0. 1 equals ln x. E equals x will be our point where we could have an extrema at. For our points of inflection, we set this equal to 0. 3 equals 2 ln x. 3 halves equals ln x. X equals e to the 3 halves would be the x coordinate of my point of inflection. So coming back over here to work with our extrema now. So we have e as our value, so we can plug in 0, we can plug in 3 to see what's going on. So when we can't plug in 0, we have to plug in, say, 1. So when we plug that into our derivative here, 1 minus ln x over x squared, when you plug in 1, you get 1, so you get positive, which means you get negative. So positive then negative means that we're going to have a relative max of e, comma, when you plug in e here, you get ln e over e, which is 1 over e. Now for the points of inflection, so we need to take our value we found over here, x equals 3 over 2. So ln of e to the 3 over 2 divided by e to the 3 over 2. I'm plugging it back into our original. So we get 3 over 2 divided by e to the 3 halves, which is 3 over 2e to the 3 halves. So our point of inflection is the point e to the 3 halves, comma, 3 divided by 2e to the 3 halves. So these problems are not always the prettiest, but they work the same as anything else. So we're told, find the points where this function is increasing, decreasing, concave up, concave down, and the points of inflection. So we want to find out everything about this. So f prime of x is equal to e to the minus x plus x times minus e to the minus x, or e to the minus x times 1 minus x. So if we want our second derivative, it's minus e to the minus x times 1 minus x plus e to the minus x times negative 1, or e to the minus x times negative x. Oh, no, forgot a negative. Oh, so it'd be negative of 1 minus x, so it'd be negative 2 plus x. So when we set this equal to 0, we get x equals 1. We set this equal to 0, we get x equals 2. So we use our 1 into our first derivative. We plug in 0, we can plug in 2. So when we plug in 0, we get a positive, which means we get a negative on the other side. So therefore, it's increasing, negative infinity to 1, decreasing from 1 to infinity. Looking at our second derivative here, around 2, we can plug in 0, we can plug in 3. Plugging in 0, we get -2. So it's negative and then positive. So that means that it is concave up from 2 to infinity, down from -infinity to 2. So we've answered increasing, decreasing, concave up, concave down, and now the points of inflection, we take this 2. So our point of inflection, we take the x equals 2 from our second derivative, we plug it in, we get 2e to the -2 by plugging back in. So that's the last piece that we have to worry about finding. It's long in the processes, but in terms of our work, it's no new work. We already know all the work. So just make sure you're kind of understanding how we can put everything together in order to do that.